teach you the convolution theorem and corollary of convolution theorem, and let me explain it by a simple example. So the statement of convolution theorem is so these are the two Laplace inverse equations. Let me get a product of these two equations, two functions. So when we get the product of these two functions, then the by the convolution theorem, so this is the statement for convolution theorem, and let me so after that let me explain, and I am going to explain a corollary of convolution theorem. So corollary of convolution theorem. Let me see the statement of this. So this is the statement for corollary of convolution theorem, and after that we see next part of that. So this is the statement for corollary of convolution theorem. So let me explain by some basic example. So example for that is, so this is a simple example for inverse Laplace. Let me solve it by the corollary of convolution theorem. So we know the form of statement of corollary of convolution theorem is 1 upon s and phi of s. So this equation we write in the form of this, and after that this is the phi of s and 1 upon s. Limit 0 to t. So we know the Laplace inverse of 1 upon s is so after that we integrate it. And limit 0 to t. After that, we apply the limit. So we get a negative sign common. So if you see the base of these two terms are common, so we write it as. So after that, this is a simple example for corollary of convolution theorem. Thank you.
Hello everyone, my name is Ram Sharafsanan. My topic is convolution theorem. So what is the convolution theorem? This is denoted by two terms of f of t and g of t. So there are examples. So we can solve this the example. So the factorization will be conduct. So x plus ti of s plus. So we can conclude the plus I of s 2 plus s square of 2 square. So we get 3 of 2 plus is of 2 plus is. Then we get the term of the 2 plus is and 3 plus I of s. So we can calculate of f of inverse. So what is our f of inverse? This is the 1 upon 2 plus I of s and 3 plus I of s. Then other f of inverse is 1 upon 2 plus I of s and 1 upon 3 plus I of s. According to convolution theorem is we can apply g of s and t of s. So what is the g of s? G of s is 1 upon 2 plus I s and f of s is 1 upon 3 plus I of s. When we can get an inverse of Laplace. So f of s 1 upon 2 plus I of s. So we get f of n is to minus 2t h of t. And the next one is g of s. So g of s we can calculate 3 plus is and we get f of e to minus 3t of h of t. So we can calculate f inverse of g of s and f of s. So we can get a so we get a f of t into g of t.
चलिए
So we can calculate the AB inverse of. So we have f of s and g of s, and the term of we get integration of 0 infinity minus infinity to infinity. Then f of u, and g of t minus u du. So we take our integration. The inverse of 1 upon 2 plus is and 1 upon t plus is.
चल चलिए
So we get an integration e raised to minus 2u of h of t and e raised to minus 3u of t minus u of du. So we can double integrate of minus infinity to infinity. So e raised to minus 2u, e raised to minus 3u, and e raised to minus 3t. So we can compute the h of u of plus t, t minus u of du. E raised to minus 3t of minus infinity to minus infinity. E raised to minus u of hu of t minus u of du. Then we calculate h of t minus u 1 0 t u 2 calculate by 2 of 0 to t. And calculate the F inverse is 1 upon 2 plus is and 3 plus I of s. So e raised to minus 3t of t2 0 e raised to u h of t minus u of du. So we can calculate plus 0 to t e raised to u h of u t minus u of du plus 0 to t e raised to u h of u h t minus u of du. So we can find the Fourier inverse. So e raised to minus 3t of e raised to u of t e raised to minus 3t of u e raised to t plus minus 1 and e raised to 2t minus 1. So we can get answer. So we can find it. The inverse of 1 upon 6 plus I of s of plus s square e raised to minus 2t and minus 3t. Thank you.
So hello everyone, this is Arun Patil from RC Patel Institute of Technology. Today we will see the application of Laplace transformation. So see their first application. It is used to convert complex differential equation to simpler form having polynomial. So next see their second application. It is used to convert derivative into the multiple domain variables and then convert the polynomial back to the differential equation using inverse Laplace transformation. The third application of Laplace transformation is they are used in the telecommunication field to send signal to both sides of the medium. For example, when the signals are sent through the phone, they are firstly converted into the time varying wave and then the superimposed and on the medium. So next application of Laplace transformation is it is used also many engineering tasks like electrical circuit analysis, digital signal processing system, modeling, ACD. So one example of Laplace transformation. So we can see the one example of Laplace transformation. You are at 0 to infinite q raised to minus 2t into sin q into t raised to t dt. So we know the formula of sin 3t. So Laplace of sin cube t is equal to, so put this value in this formula. Laplace of 3 by 4 plus sin t minus 1 by 4 sin 3t. So simplify it, so we get 3 by 4 plus 1 by a square plus 1 minus 1 by 4 plus 3 upon a square plus 9. So this means integration 0 to infinite q raised to minus st sin cube is equal to 3 by 4. Stop. Plus 1 by a square plus 1 minus 1 by 4 plus 3 by a square plus 9. So next, putting this value, putting this is equal to 2, and we get integration 0 to infinite q raised to minus 2t sin cube 3 sin cube t dt is equal to 3 by 4 plus 1 by 4 plus 1 minus 1 by 4 plus 3 by 4 plus 9. So we get our answer 6 by 65. So answer of this example. So thank you.
My name is Ashita Patil. Today I take the example of application of Laplace transform. So example 3 divided by dx plus 2y is equal to e raised to 2t, y is equal to 1 and the t is equal to 0. Let's start by taking Laplace transform on both sides. So we have get the Laplace of y dash plus 2 into Laplace of y is equal to Laplace of e raised to 3t. So we put the value of y dash, y and e raised to 3t, Laplace of e raised to 3t. So we have 3 into bracket s dash minus y naught bracket complete plus 2 into y bar is equal to Laplace of e raised to 3t is equal to 1 upon s minus 3. So we know that the value of y naught, so we can put the value of y naught in this. So we have need the s minus, but y naught is equal to 1. So we can put y naught is equal to 1. So we have get is equal to 1 upon s. So y bar is equal to 3s minus 8 divided by this term s minus 3 into 3s plus 2. So we can simplify this. Y bar is equal to 30 divided by 11 into 1 upon this term 3s plus 2 plus then plus 1 upon 11 into 1 upon s minus 3. So by partial fraction, so we can write this on this side. Y bar is equal to 10 divided by 11 into into 1 upon s plus in bracket 2 divided by 3. So plus 1 upon 11 into 1 divided by s minus 3. So we can take inverse Laplace. Taking inverse Laplace. So y1 is equal to 10 divided by 11 Laplace inverse of in bracket 1 divided by s plus 2 divided by 3 bracket complete plus 1 divided by 11 Laplace transform of 1 divided by s minus 3 bracket complete. So we can apply the Laplace inverse. So we can get the 10 divided by 11 Laplace inverse this term, Laplace inverse of this term. So 1 upon 3 plus 2 divided by 3 Laplace, its Laplace is e raised to minus this term 2 divided by 3 and plus 1 upon 11 into Laplace inverse of this term e raised to 3t. So we get the final answer of this question. Take a second example of application of Laplace in Laplace transform. So the taking Laplace transform on the both sides. So let's take the Laplace transform. So Laplace y dash plus 3 Laplace of y is equal to Laplace of 2 plus Laplace of e raised to minus 2. So we can take the value of y dash y and e raised to minus 2. So Laplace of s y dash minus y naught plus 3y dash is equal to 2 into 1 upon s plus 1 upon s plus 1. But we know that the value of y naught is 1. But y naught is equal to 1. So put the value of y naught. So let's y1 is equal to s square plus 4s plus 2 divided by s plus 1 bracket complete into in bracket s plus 3 by the partial fraction you know that the partial fraction y1 is equal to 2 upon 3 into 1 upon s plus 1 upon 2 into 1 upon s plus 1 minus 1 upon 6 into 1 divided by s plus 3. So we can taking the inverse Laplace. Taking inverse Laplace. So y1 is equal to y. So y is equal to 2 upon 3 plus 1 divided by 2 Laplace of this term e raised to minus t minus this term 1 upon 6 into Laplace inverse of this term e raised to minus 3t. So this is our final answer.
And here we see that the application of Laplace transform in which we will solve about the RLC circuit. So first we will take the RLC circuit. This is a question in which we have to find we have to solve it using the Laplace transform. So in this question first we will take the Laplace on both sides. Then the equation became the Laplace is equal to s into q complement plus q into 0 plus 1 upon c into q complement. And we know that the Laplace of 1 is equal to 1 by s. Therefore, here is the equation 1 upon s. Here we know that q of 0 is 0. Therefore, r is q dash plus 1 upon c q dash is equal to v by s. From this term, we will common out the q complement. Therefore, q complement is equal to rs plus 1 upon c is equal to v by s. This this term will be divided here. Therefore, Q complement is equal to V by S into 1 upon Rs plus 1 by C. In this, the Q complement became the V by S into C upon RCS plus 1. Therefore, Q complement is equal to Vc upon S into RCS plus 1. Therefore, the Q complement became Q complement is equal to Vc L inverse of 1 upon S minus Vc square L inverse of 1 upon RCS plus 1. Therefore, Q complement is equal to Vc L inverse 1 upon S minus Vc L inverse 1 upon S plus 1 upon Rc. Therefore, by taking the inverse Laplace on both sides, equation became Q complement is equal to Vc L inverse 1 upon S minus Vc L inverse 1 upon S plus 1 upon Rc. Therefore, Q complement is equal to Vc minus Vc into e raised to minus t upon Rc. In this, we will common out the Vc. Therefore, Vc is equal to 1 minus e raised to minus t upon Rc. RL circuit. So here we will apply the same of stage that taking the Laplace on both sides. Laplace on both sides. Therefore, equation is equal to L into Laplace of I dash plus R into L of R is equal to E into L of e raised to minus 8. Here the equation becomes A is equal to S into I minus I of 0 plus R into R. Here the I dash. Therefore, A is equal to 1 upon S plus A. We will common out the I dash. Therefore, Ls plus R into I complement or I dash is equal to E upon S plus A. Therefore, the I dash became I complement became E upon S plus A into 1 upon Ls plus R. Therefore, I dash is equal to E upon S plus A into Ls plus R. By taking the partial fraction, equation became I dash is equal to E upon LA into 1 upon S plus A minus plus EN. Therefore, EL upon R minus LA into 1 upon R plus LS. By taking the inverse Laplace, equation became I complement is equal to E upon R minus LA into L inverse of 1 upon S plus A minus EL upon R minus LA L inverse of 1 upon R plus LS. So, by taking the inverse Laplace, the equation becomes E upon R minus LA into e raised to minus 80 minus E upon R minus LA into e raised to minus R upon LT. So, by we will common out this E minus R upon LA, therefore I complement became the E upon R minus LA into e raised to minus 80 minus e raised to minus R upon L into T. Here we end our video. Thank you.